Okay, what we have today for our lesson is working on learning how to simplify and solve when you have square roots in a problem. So today's note sheets, you're going to have this full-size paper that you're going to fold just like this. This will get taped in so you can read the front and then still open up the inside. And then you have this half sheet of paper with the practice problems on it that you're going to do. And again, make sure your table of contents is filled out, and we'll tape on page 109, 110. So, first thing you need to know about square roots and square numbers. We have this symbol called a radical symbol. And the radical symbol allows us to work with numbers. In this case, we have an index of 3. And the index of 3 means we need 3 matching numbers that multiply to give us 125. So we know that the answer is 5 because 5 times 5 is 25, and then 25 times 5 is 125. So we're able to solve problems with a square root symbol. In this case, it would be a third root because we have an index of 3. So just label index, put this example in there. This again is the radical symbol. It is important to note here, though, that if you do not have a written index, it is understood that it's automatically a 2, that you're looking for 2 matching factors. So we're going to focus mostly on square numbers and square roots today, but here's a little bit of the vocabulary you need to know first. The number inside is called the radicand, and the whole thing is called a radical. All right, so sometimes you'll hear this called a radical symbol instead of just a square root symbol. Now the next part of your note should look familiar because we did talk about this earlier in our last unit. For right here, I just want to remind you, a square number is when we take that number and multiply by itself. So over here, you're just taking 1 times 1, and you're getting the answer of 1. And then you're doing 2 times 2, and you're getting the answer of 4, and so on and so forth. So we want you to have a table filled in of all the square numbers. Remember, you can use your calculator if you need it to put that exponent in there to quickly get your solution. Also down here, what I'd like you to fill out is practicing working with square roots. The square root button, I believe, to access it on your calculator, you have to hit the second button, which is blue, and then you have to hit the x squared button, which gives us the ability to do square roots. If you just think in your head what number multiplied by itself gives me 1, we know it's 1 times 1. What number times itself gives me 4, you know it's just going to be 2. So take a minute, fill these 2 tables in. Understand down here at the bottom we're mentioning that inverse operations allow us to undo things. So of course, squaring and square rooting, once you see what happens when these tables are fully filled out, you'll understand why they undo each other. So pause the video, fill in your chart, and then play so you can check your answers. Again, check your chart to make sure that you do have all these values that were squared done correctly. If you notice, you have matching values down here where we're undoing those numbers with a square root. So of course, undoing or using inverse operations, or you might have called them opposite operations in 7th grade when you were first learning about inverse operations. These allow us to do some things with mathematics so that we can solve problems. So the first type of problem you're going to get is just a square root problem, possibly with some numbers and letters. So the deal is you go ahead and you take the square root of the number part. We know when you square root 9, you're looking for what number times itself equals 9. So of course it's 3. 3 times 3 is 9. So that's why we get 3 for the number part of it. Now variables are a little bit tricky, but just remember a variable squared means we must have had an x times another x to create x squared. So if you're breaking it apart to figure out what the separate values are, we're just going to have x. Okay, that variable comes out alone when you do a simplifying problem. Now if you ever get a fraction to simplify, understand that you can separate the numerator from the denominator. But notice how they all have their own little square root symbol. So the square root of 25 is just 5, remember, because 5 times 5 is 25. And the square root of 4, remember, is 2 because 2 times 2 is 4. Okay, so you should be able to simplify expressions that have letters. You should also be able to simplify fractions as well as just plain old numbers. Now, technically all positive numbers have two square roots, a positive and a negative square root. To indicate the positive and the negative square root, we stack the answers together like this. So let's say we have a problem like this that we're solving. We need to know what number squared equals 25. What we will do is we will take the square root of both sides, because we know that square roots and squaring undoes each other. So you can kind of like cancel them out to get x. And then if you recall, 5 times 5 gives you 25, but we also have to indicate that there is a negative answer of negative 5 times negative 5 that also gives you 25. So we need to indicate both solutions for this, so that's why we stack together the plus and the minus sign. Here's an example where you're going to take x squared and figure out what number times itself is going to equal 4/9. The best way to show that, again, is to undo that exponent, to square root both sides. So you will cancel out the squaring, leaving you with just x. And if you remember what we talked about with fractions, you can square root the numerator separate from the denominator. So I think you can see how we can get 2/3 right away. But we need to sneak in our little plus minus sign because we have two options, a positive and a negative solution. Your last example is kind of sideways on your note sheet, so just turn your paper. It's the same type of question where you're going to square root both sides to get rid of the squaring. They undo each other. But when you go to figure out what the square root of 18 is, you don't have an exact value. Okay, the other problems we just did were called perfect squares. They have perfect values. 5 times 5 is perfectly 25. 2 times 2 is perfectly 4. 3 times 3 is perfectly 9. This whole chart that we filled in the front is full of things that are called perfect squares. When you get a number that does not have a perfect square like 18, what we have to do is look in the calculator, and typically what you'll be asked to do is round it to a specified place value. I think I put hundreds on here. So again, to do a square root, you're going to hit second x squared, and you're going to put in your 18, and you're going to see that the answer is approximately 4.24. All right, so for our purposes, we're going to take answers that aren't perfect like this. We're going to round it off to the nearest hundredths place so we can get an idea of approximately what the value is. Now, on the half sheet of paper, you've got 6 problems to practice by simplifying. So remember we talked about the number itself is going to pop out a certain value, like this part here, the square root of 25, we knew is 5. The variable, remember, anytime a variable is being squared, you're going to pop out a single x value. So I want you to take a minute, pause the video, go through those examples, try them on your own, and then check your answers. Here's that 5x that we talked about. Square root of 16 is 4, and there's your variable that pops out. And then to practice with the fractions, separate the numerator and the denominator. Square root of 100 is 10, square root of 196 is 14. If you wanted to, you could reduce this fraction a little bit farther because the top and bottom both divide by 2. So we could put it in simplest form and call it 5/7. Same thing with number 4. When you separate the numerator and denominator and you get your values, you could reduce this one. You could divide by 2 top and bottom, or I'm sorry, 3 top and bottom, so your resulting fraction can be reduced. You can say 2/3. Square root of y squared, these undo each other, so you get y. Square root of 225 is 15. On the last little piece of your notes, you've got some equations to practice. So remember, when you have an x squared equal to something, you're going to square root both sides. If your value comes out perfectly, you just go ahead and get that value. For example, 10 times 10 is 100, so don't forget the plus minus. On an example like this over here, when you go to square root 14, you're going to see that, again, you've got a value that is not going to come out very nicely. So again, we're going to have you round that off. So the square root of 14, it's approximately 3.74. So please round your answers to the nearest hundredths place. Pause the video, try these examples, then come back and check. Okay, let's see how you did. Remember, you want to make sure you're taking the square root of both sides. You're solving an equation, so you want to keep it balanced, just like we talked about when we were solving equations in 7th grade and earlier this year. Make sure that when you get numbers that have perfect values, you go ahead and find that perfect value, like these two questions. Another one with a perfect value here, number 14. You don't get a perfect value, so remember we said when you take the square root, you're going to get the answer rounded off a couple decimal places. And again, check the last couple. If you have any questions, be sure to let me know. Get this taped neatly in your notebook.